All right, and the other big kind of measure besides central tendency are measures of variation. So that's like how different is all the data. And there are two main ways that we talk about doing that. The first you've done in math, and so that's range. What's your lowest, what's your highest, and then you take the highest number and you subtract the lowest. So it just gives you a complete spread. And that's a quick rule of thumb. But when you have a lot of data and you have outliers, like we saw in that family income distribution, for example, the range would have gone from 710,000 to 0, which is a really big range. We really like to use the standard deviation instead, and that's kind of like you calculate the arithmetic mean. The standard deviation it's actually an average of how much each data point deviates from or is different from the mean. So you add up all those deviations for every single data point from the mean, and then you divide by the number of data points. And then technically you take the square root, but that's kind of outside of since you're not going to be calculating standard deviations directly, it doesn't really matter. But the important thing is when you end up with a small standard deviation, it means your data is really clustered in the middle. And when you have a large deviation, it means your data is really spread out around the mean. All right, and this is an example of why you don't really want to have to calculate standard deviation by hand. And this is an example of a bunch of exam scores. So they are spread from 87 to 72 over here on the left, and on the right they're spread from 100 to 60. So the range here is 15 on this side. The range in this set is 40. So the average, when you do the arithmetic mean, it turns out to be 80 over here on the left, and it actually also turns out to be 80 over here on the right. So those are two groups of data that have the same mean, but it's going to turn out that they have a really different standard deviation. So, like I said before, what you actually do is figure out for each data point how far is it from the mean, and then you technically square that, and then you divide it by the number of scores, and then you take the square root of that. So the standard deviation over here on the left is 5. If you do the same thing over here on the right, it's 15.8. And so this tells you that the cluster of data is very close around the mean over on the left, and it's very spread out over on the right. And if we graph these in Excel, which I think might be a good thing to do, you would see exactly that. So going back to normal distribution in a little more depth, I think I said this before, but the important thing is that there's so many kinds of data that if you order it from the lowest to the highest, and then you count how many times you get that data, it ends up being shaped like a bell curve. And so this is the dark blue line here, shows the normal distribution that best fits this data. The underneath part, the chunks are called a histogram. And a lot of different experimental work data that's collected in experiments ends up being normally distributed. So this is something you're going to see a lot and will likely see on the AP Psych exam. And I described what this was a little bit before, but it's these 50 different data samples of the weight in cereal in ounces produced by this second machine. All right, so things to notice about it. The average or mean is 12.4. That's right in here. And the standard deviation is only 0.1. And so almost all the data, 68%, as we'll see in a minute, happens between 12.3 and 12.5 ounces. And so that brings us to one of the really important rules about normal distributions and why they're important. So normal distribution is actually a probability distribution. And so it is a curve that basically it's graphically demonstrating how frequently data occurs from the lowest possible to the highest possible point. Technically, it's minus infinity and infinity for a continuous graph, but usually we'll have bounds there. And so the important thing here is a couple of symbols. So this funny looking a U is called a mu, and that's the symbol that we use for the mean when we're talking about what's called a population distribution. The sigma, or this thing one of my math students actually called it the circle with the hair flip. So sigma represents standard deviation. So like for the cereal, our mean of 12.4 would go right here in the middle. And then we go up and down standard deviations. So the next one up would be 12.5, 12.6, and 12.7. We'd go down and label the horizontal axis 12.3, 12.2, 12.1. And then these percentages represent the percent of data that falls within that range. So 34% of the data should fall between these two vertical dashed lines. So I know this is a little bit abstract and I have some problems to work if you want to, but it may be enough to just get familiar with the vocabulary for AP Psych. The other thing to know, and hopefully you already know this from math, is that percentages are directly related to probability. And so 100% of the area here is part of or contained under that bell curve. And the total probability of 1 is also contained underneath that bell curve. And so whatever percent you figure out, probability is actually just take that percent and you divide by 100 to get the probability, or P. So the last thing is what these the empirical rule actually says. It's sometimes called the 68, 95, 99.7 rule. And that tells you that 68% of all of the data, or all of the probability, 0.68 of the probability, falls between -1 standard deviation from the mean and +1 standard deviation from the mean. And if you go out 2 standard deviations, then a total of 95% of all the data, or 0.95 of all the probability, are going to happen between the mean -2 sigma and the mean +2 sigma. And then finally, if you go out to the 3 standard deviation points below and above the mean, 99.7% of all the data falls within the mean -3 standard deviations and the mean +3 standard deviations. So this is a very standardized way of figuring out probabilities, which is very helpful in statistics, and very appreciate you joining me for this, what turned out to be a little bit longer than I expected video, and I look forward to working with you.